In physics, a very important quality that needs to be considered is the difference between a vector and a scalar quantity. A vector is going to be any quantity that has both a magnitude and a direction. Now, what could be an example of that? Well, if I'm at point A and I want to move to point B, I can't just say, well, go 30 meters, because 30 meters could be anywhere along this radius. I need to go 30 meters that way. So not only do I have a magnitude, I have that distance, that amount of distance that I need to travel, I also have the direction that I need to travel in. I could also have that for a velocity or an acceleration, or if I'm applying a force to something. If I've got a box sitting on a table and I want to push that box to the right, if I try to apply my force down, that box is not going to move. I would need to apply my force in that direction, in the right direction. So a vector is going to be a quantity that both the magnitude, the amount of it, and the direction is going to play a factor. A scalar quantity is going to be one that the direction doesn't matter at all. And some examples of this could be time. Time is just going to be marching onwards. It's not going to have a specific direction. It's not like I go, yeah, so it's going to be 5 seconds to the right. No. It's 5 seconds. If we're moving to the right, we're moving to the right, but it's going to be for 5 seconds. Another example is mass. My mass is in no particular direction. It's a quality about me. I have a mass. I possess mass, but I don't have a direction for that mass. If I start moving, well, that could be in multiple dimensions. So let's get rid of some of this. So I might say I'm going to move 10 meters at 15 degrees, and then I'm going to move another 10 meters at, let's say, let's call this is definitely not 15. So if I'm working with vectors, I need to be able to add in vectors. And so a vector is going to be some magnitude, so let's say this is 10 meters, and some direction, let's say it's 45 degrees. And then let's give a second direction. Let's say this is another 10 meters, and let's say it's at 15 degrees. I need to be able to figure out what is this total? What is this total vector right here? And to do that, I'm going to add up the x quantities and the y quantities of my vectors. Because when I do that, when I add these together, if I can break this into an x and a y, well then, that gives me the same distance. So then that overall direction would be my total vector. So when I want to add these together, the first thing I need to do is break them up. And that's going to be done just using some nice, simple trigonometry. So I can say that this is my hypotenuse. This is going to be my adjacent side, and this is going to be my opposite side. And this is the angle I'm working with. My 10 meters, that is my hypotenuse. That's the amount of my hypotenuse. So I need to remember SOHCAHTOA. And I need to remember Pythagorean theorem. A squared plus b squared equals c squared. These will come in extremely handy when we work with direction. So first off, let's figure out my x component. That's going to be right here. That's going to be my adjacent side. So in order to use the adjacent, that means I'm going to use the cosine, because this is going to be ca means cosine of theta equals my adjacent side over my hypotenuse. And so I can rearrange this equation to solve for a by multiplying both sides by the hypotenuse. Well, I just said the hypotenuse was 10, so I can do 10 times the cosine of my angle, and this first one is 45. 45 equals my x coordinate. It's going to equal x. Okay, let's do that. And that's going to give me 7.07 equals x. Okay, let's do the same thing for y. My y is going to be using the SOH. So it's going to be the hypotenuse times the sine theta will give me the opposite side. So I can say 10 times the sine 45 gives me my y. So I can take that And sine of 45 and cosine of 45 are equal to each other, so this is going to be 7.07 as well. Now I can do that for my 15-degree angle. Let's try that again. So the only thing that changes here is that I'm going to a 15-degree angle for both of these. So if I put these into my calculator, I should get two different values this time. 10 times the cosine of 15 is going to give me 9.66. So this guy right here, this is going to be 9.66. And then for 10 times the sine of 15, I get 2.59. That's 2.59. And so if I wanted to figure out my resultant vector, I would just add up these components. So my total here is going to give me 16.73 for x. And it's going to give me 9.66 for y. So then those are my components for my total vector. So just to start off, what we're going to be doing is breaking our vectors into their individual components. So you're going to be using sine and cosine and treating each vector like it's its own individual triangle in order to give us the actual components of it. So each vector is going to get split up into an x and a y.